We know that a graph of a function shows us all the x, y ordered pairs that satisfy that particular function. Now, all functions must pass the vertical line test. What that means is that if we have a graph of a function, we should be able to draw any vertical line and it should hit the graph in at most one place. If it hits more than one point, then it's not a function. Let's take a look at these two and see what we think. If I look at this first graph right here, I should be able to imagine vertical lines, multiple different places, that only hit the graph one time, such as right here. You can do another one right here. Only hits your graph one time. This is a function because it does pass the vertical line test. But if we look at this one over here, there's plenty of places that if I draw an imaginary vertical line through here, I see that it hits my graph here, here, and here. Means that when x is 2, there are 3 different y value. Okay? We can't have that. We know that each input value or domain value has to have only one range value. This is not a function because it doesn't pass the vertical line test. The domain, the range, and the intercepts can all be found by looking at your graph. So if I look at this first graph, I know that domain values talk about the x values. So I'm looking along the x-axis. Let's start by talking about the domain are all the x values. So I want the smallest x value I see, which is over here at -4. So if I write that in interval notation, I can say that the domain goes from -4. And notice I did it with a parenthesis because that's an open circle. It tells me that -4 is not a point on the graph. It's just your starting place. And as I travel along the x-axis, the farthest point to the right, or the largest value I see, is at +7. Notice +7 has a closed circle. It means 7 is part of the domain value. It's included. So we want to put that hard bracket there to tell us that that's included. You can also write domain values instead of in interval notation like this. You can write them as sets. We can say that the domain is all of the x values such that -4 is less than x and x is less than or equal to 7. We can do the range values exactly the same way. Range values, we know, talk about the y values or the output values. So we're looking here along the y-axis, and I want to look for my smallest y value. As I walk, I see that -3 right here is the smallest y value. Again, I'm going to put a parenthesis because it's not included. And then I want to keep going along the y-axis and look for the highest point on the graph, which the highest point is right here, which corresponds to this y value of 4. And because it is a point on the curve of the graph, it is included. So if I want to write that as a set notation, I would say that y such that -3 is less than y, which is less than or equal to 4. Now I can also find my intercepts from the graph. Okay, the x-intercept is simply the values where the graph crosses the x-axis right here. So I want to look and see the x-intercepts looks like right here at -3. There's another x-intercept right here at +3. And as you keep going, there's an x-intercept at 6. So I know that all these have a y value of 0. So my x-intercepts are the points -3, 0, +3, 0, and 6, 0. And I can do the same thing to find the y-intercepts. I look at the y-intercepts are all the points where the graph crosses the y-axis, right here. So I'm looking, and the other place I see where it crosses the y-axis is right here at about 3.5. So we'll say 3.5. I know the x value, it has to be 0 for an intercept, so my y-intercept is the point 0, 3.5.